Today we're going to be talking about solving systems by graphing again. So there's three different situations that we can be in, the way that our graphs would look once they are put on graph paper. So the first one is if we have our two lines, then when we graph them, it looks something like this. And so how many solutions would this system have? Well, it crosses in one place, so this would be one solution. Okay, if we graph them, we graph both lines on there, and they look like this. What type of lines are those? So those are parallel. If they're parallel lines, how many times do those touch? So they don't touch at all, so this would be 0 solutions or no solutions. And then the last one is if we graph both lines, but it only appears to be one line on the graph. This would be infinite solutions, because they share every single point in common. So every single point on this line would be the same as every single point on the other line, and so then that would be infinite solutions. So let's talk about when these would happen. So if they have one solution, that means that they're going to cross somewhere, which means we're going to have different m values, different slopes. If they have different slopes, that means that they're going to cross somewhere. Parallel lines, for no solution, parallel lines. What do we know is true for parallel lines? So those are going to have the same slope. I don't know why I spelled it out this time instead of putting m. So same slope. But what do we know about their y-intercepts? So those are going to be different y-intercepts. Okay. And if they're infinite solutions, they're going to have the same slope and the same y-intercept because they are the same line. Okay, so those are the three situations that we're in. If we're just looking at two equations in y equals mx plus b form, we should be able to know or predict what type of situation we're going to be in based on that. So let's try a few to continue on from what we did yesterday. So first set for today, this is example 4 continuing on from yesterday. Y equals 3x minus 6, negative 6x plus 2y equals negative 12. The first equation's already solved for y, so we're going to go ahead and just figure out what m and b is, or what m and b are, and we're going to graph it. So here we would have m is 3 over 1, and b is a negative 6. So we're going to plot the b first. We're going to begin with b, and then our slope is 3 over 1. So we're going to rise 3 and run 1. And remember, when we're making this first graph, we're going to plot as many points as possible for that one. And then we're going to connect them. Okay, for the second equation, negative 6x plus 2y equals negative 12, that's not ready to go yet. We have to do some more work for that. So we're going to add the 6x over. And our x's, whoops, that should be minus 12. Our x's are going to go first. And then we're going to divide by 2 to each term. So that means we would have y equals 3x minus 6. Now what do you notice about this equation and the first one that we had? Well, they're the exact same thing. They have the same m and the same b. That means when I go to plot these, it's going to be the exact same points that I just plotted before. Well, that means they're just going to be on top of each other. They share every single point in common. So this would be infinite solutions. Okay, that's one of our special case situations that we're talking about today. Infinite solutions for that one. Okay, here on this one we have y equals negative 2/3 x plus 4 and 2x plus 3y equals negative 6. So the first equation in this case is ready to go. You can say m equals negative 2/3 and b equals a positive 4. We're going to begin with b. We're going to plot that y-intercept up at +4. And then our slope tells us that we're going to go down 2 and right 3. I'm going to keep doing that, plotting my points as I go, making as many as possible. And then we're going to bring in our ruler here and connect the dots. So the first equation is done. Now moving on to the second one, 2x plus 3y equals -6. To get y by itself, we need to subtract 2x from both sides. And second step to getting y by itself is to divide by the coefficient of y. We don't know what -2/3 is. That doesn't simplify as a fraction at all, so we're going to leave it alone. And then here, -6 divided by 3 is a -2. So when you're looking at these two equations in slope-intercept form, they have the same m of -2/3, but the b value is different. So this b value is -2. So when we go to plot this, we're beginning with that b value and then going down to and right 3. And no matter how many points I make on this, are those lines ever getting closer together or ever going to touch? So no. Okay. If you're looking at the two equations and you're noticing that they should be parallel lines, but when you're graphing them, they're not coming up as parallel lines, you know that you definitely did something wrong. So those two are parallel lines, which means they're never going to cross. So we would say no solution, or no solution or zero solution would be our answer there. Okay, so let's look at one more. This one looks like it's ready to go for us with x equals -2y plus 1 and x equals y minus 5. However, we have to make sure that y is the thing that's by itself. Okay, so for this first equation, let me rewrite it down here so we can work with it. We got to get y by itself. So in this case, we're going to move the constant, and it doesn't matter if x is by itself on the left or on the right. And then we're going to divide each term by a -2. Now, what number's in front of this x? That's a 1. Okay, so this will be -1/2 x plus 1/2 equals y. Y is still by itself. It doesn't matter if it's on the right. Okay, so here our m is going to equal -1/2, and our b is going to equal a +1/2. So the thing that makes this question a little different is that's b value is not very easy. Not very nice. So we're going to start at 1/2 there. Okay, and then we're going to rise -1 and run 2. So we're going to go down a full space and write 2 spaces. Down a full space, write 2 spaces. So you're not going to be in a nice, easy place for these points, and that's okay. You're just going halfway in between, but we're still following our slope. So we're going to connect those. And then move on to the second equation. So we have x equals y minus 5. So if we have that equation, and we're trying to get y by itself, we're going to add 5 to both sides. So x plus 5 is going to equal y. That means our m is going to be 1/1, and our b is going to be a +5. So we're going to begin with b here. Now, if I go up 1 and right 1, am I getting closer to that other line at all? No, so we're going to keep going here. Now, I didn't mark that actual point before, but that is a point because I've made my first line very accurate. That is a point that has crossed, or that has been marked on the red line that I marked first. So let's work on connecting these dots. And then we're going to find that point where they cross. So we went -3 in the x direction and a +2 in the y direction, which means that -3, +2 is our answer. Remember, you can check your answers by plugging these back in or going to the Desmos calculator. Keeping in mind that when you're looking at things, there's one of three possibilities. We can either have one solution. We know that there will be one solution if the two lines have different slopes. Zero solutions or no solutions if the lines are parallel, so they have the same slope but different y-intercepts, and then infinite solutions if they have the same slope and the same y-intercept.